Welcome dear students. I am Rajiv Lohani and today I am here to discuss with you what are called the equations of motion. You know that if a particle is traveling with a constant speed, then you determine the distance traveled by using the equation distance equal to speed into time. This equation is valid if the velocity or the speed is constant, or if we are using the average velocity of the given particle. But the equation does not hold true if we want to use it for a particle which is moving in a straight line with uniform acceleration, suppose a. For determining the distance traveled in such cases, when the particle is uniformly accelerated, we require some different equations, and those equations are true not only for the uniform motion, they are also true for uniformly accelerated motion. That's why these equations are called equations of motion. There are three such equations. If we denote the initial speed of a uniformly accelerated particle by small letter u, its acceleration by small letter a, final speed by the small letter v, distance traveled by small letter s, then the three equations of motion are: first, v equal to u plus a into t. Second, s equal to ut plus half at square. Third, v square equal to u square plus 2 into a into s. I will derive these three equations in three different ways. The first way will be the simplest one. The second way will be derivation of these equations from the speed time graph of the given particle which is moving in a straight line. And the third method of deriving these equations will be the method of integration. So let us begin with the first method, and let us first derive the equation v equal to u plus at. You know that acceleration a is defined as the rate of change of velocity. That is, a is equal to delta v upon delta t, where v is v minus delta v is v minus u, and delta t is t minus t1. Here we'll take t1 as 0, so delta t is equal to t. So this equation becomes a equal to v minus u upon t. If I cross multiply it, it becomes a into t is equal to v minus u. Rearranging this equation, we get v equal to u plus a into t. This is the first equation of motion using the first method of derivation. Now come to the equation s equal to u plus ut plus half at square. If the motion of a particle is uniformly accelerated, we can write the average velocity of the particle as its final velocity plus initial velocity u divided by 2, so that the distance traveled by it in time t will be s equal to average velocity multiplied by time t, that is equal to v plus u upon 2 into t. But from first equation we have v equal to u plus at, so we can replace v by u plus at. So we get s equal to half is this 1 upon 2 into u plus at for v plus u into t, that is equal to half into 2u plus a t into t. This gives us s equal to half into 2ut plus at square when I multiply the terms inside the bracket by the term t. This becomes, on multiplying by half, it becomes s equal to 2 and 2 will cancel, ut plus half at square. This is the second equation of motion. To obtain the third equation, we will start from the first equation, v equal to u plus at. Now square it on both sides, we will get v square equal to u plus at whole square. On expanding it, we get v square equal to u square plus a square t square plus 2u at using a plus b whole square equal to a square plus b square plus 2ab. This gives us v square equal to u square plus, from these two terms we will take 2a out, and inside I will get a square t square when divided by 2a, it will be at square upon 2, plus when this term is divided by 2a we get ut. So this becomes at square upon 2 plus u into t. It means v square equal to u square plus 2 into a into, you can see this is ut plus half at square. It means this is s. So we have the third equation, v square equal to u square plus 2as, and this way, using the first method, we can find out the three equations of motion. If any particle is under uniform motion, then you will only write a equal to 0 and get your work done. We'll meet for the next method very soon. Till then, goodbye. Thank you.